So in the chapter so far, sorting materials into groups, we have learned about in the chapter sorting materials into groups. We have learned about various concepts, right? So we have learned about concepts like why, there are so many objects around us, and like you see chair or different kind of things around us, right? And they need to be sorted into groups for various purposes, so that we'd be having convenience in grouping them, in studying them, in comparing them, and in order to save our time whenever we have to look for it. Getting it, guys?
Yes, sir.
So those things that we see around us, they need to be grouped for the following purposes: to save our time in finding the given objects, or to save our energy. Grouping makes the place look well arranged and beautiful. Yeah, Ira, good. And for the purpose of convenience in storing them also, for the purpose of convenience in having studying them also, for that purpose. We did learn about classification, and thereby I did told you guys that it's the process of sorting and grouping materials according to some of the basic similarities that they will be sharing, right?
Sir, like color, shape.
Exactly, color or shape, like that, or the type of material they are made up of, whether they are made up
Sir,
of.
like what, like if they do like the same type of thing.
Yeah, exactly. They have same use, right? Getting it?
Yes.
So that is the thing. The basis of grouping, as you guys were saying, it would be either shape, the type of material they are made up of, or how they appear, like based on whether they are shiny or non-shiny, whether they are hard or soft, what is their texture, do they get dissolved in water or not, how much amount of light do they allow to pass through it, or do they not allow any light to pass through it at all, do they get attracted towards a magnet or not. So this was the basis of grouping different materials into different groups. So these are the similarities that they would be sharing. Okay. We also know that the different things that we see around us are basically one general way to classify them is as living things and non-living things, and following are the properties of the two. Living things can grow, breathe, respire, move, respond to the stimulus that they can feel, and they can reproduce. Non-living things can't perform any of these actions right now because they don't have cells in them. They are not made up of cells, right?
Yes, sir.
We know. Then we did learn about materials. So material would be any physical substance that would be used to make things. For example, to make paper, you need wood. So wood is a material, right? To make clothes, for example, to make a t-shirt, for example, you require some fibers. For example, you'd be requiring cotton as a raw material, right? Or to make gunny bags or jute bags, you'd be requiring jute. So that is the material required for making the jute bags. Getting it?
Yes, sir.
And etc. We have several other examples. For example, we have to construct bridges. So in order to construct bridge, we would be requiring some raw material that would be iron, like that. Okay. Furthermore, the different objects that we see around us, sometimes they can be made up of more than one objects. For example, a stapler, a pencil, etc. would be made up of. Yeah, volume slum, Halima. Okay. So we have just revised the different things which we did learn in the previous class. First of all, yeah, Halima.
Last time we have done basis of grouping, right?
Yeah, basis of grouping, we have done that.
Can I
Okay, no?
write the last line of it?
Yes. One moment. Yes. See, basis of grouping, which you guys also wrote. You guys wrote down this also. Right
Yes,
now, we
sir.
are going to continue from the different bases of
Sir, can I write?
grouping.
There is only last line for me to write.
You had missed something in this one?
Yes. Yes.
Okay, write it down. And all of you turn your cameras on in the class.
Sir, I forgot to charge my tab, so I'm sorry.
Okay, no worries, no worries. So let us continue from here. Meanwhile, quickly write it down.
Just 1 minute, sir.
So we would be learning about, first of all, based on the appearance, what are the different objects which we have. Okay, no?
Yes.
And Halima, you have shared your syllabus, no, by the way. Good. Other, you guys
Sir,
also
I
have
shared
shared.
it already.
Good,
Sir, I
good,
shared it.
good. Okay. So based on the appearance of the materials, we have shiny object and we have non-shiny object, or basically we have lustrous and non-lustrous objects. So based on whether how they look, the objects can be classified as lustrous or non-lustrous. Some of them are very shiny, like this gold, so they have luster in them. Right now,
Sir, some of them are not that shiny as gold, like
hmm,
bronze.
bronze, but that will also be taken as a shiny object. Right now, getting it.
Yes.
Hmm. So
Sir, like
materials can
clay, like that's not shiny.
exactly clay or rock, etc. They are not shiny objects right now. Okay, even
Sir, diamond
sometimes,
is a luster object.
yeah, it's the most lustrous, one of the most lustrous object which we have. Okay, no? So some materials have luster. Right now, they would be glowing, while others would be plain and would have a dull appearance. Right now,
Yes, sir.
usually in nature we found that most of the metals are shiny. Like copper is shiny, a fresh iron, freshly cut iron is shiny, gold is shiny, mercury is shiny. Getting it, guys? So most of
Yes,
the metals are shiny, they have a luster. Yes,
sir, silver as well, right?
silver as well. So we have several examples of that. So generally, metals are shiny. It is the property of metals that they are shiny. So as we have example of gold, silver, mercury, copper,
Sir, should we
right?
write?
I will tell you guys what you have to write down. Okay, no?
Okay, sir.
So mercury is there, copper is there, a freshly cut iron, because iron is a
Freshly
metal
cut,
that, yeah,
sir, even freshly cut iron is also shiny.
yeah, that's what we are learning, that it is also shiny, but after some time it will be losing its luster because it reacts with the moisture present in the air. It reacts with oxygen and
Sir,
water
like it
and
will
becomes
become
rusty.
Sir,
rusty.
yeah, it will become rusty.
Exactly. Right now, so therefore usually most of
Sure,
the
sir.
freshly cut metals would be
Sir,
shiny.
diamonds, pearls are also shiny, right?
Exactly, but diamond is a non-metal, by the way. Okay, no? So we
Yeah.
have some examples of non-metals also. So we have example of like
Diamond.
diamond as you give
Pearl.
right now, and you have
Sir, and
different
pearls
examples,
also.
pearls also, right? So those are examples. Those are also examples of shiny objects, right? Generally, we have some metals which will not lose their luster, like gold and silver or mercury. They will not be losing their luster in a long
Copper.
time. Huh. Copper would be losing its luster. After some time, it loses its luster. So we have copper or
Sir, it will
iron,
become copper and iron will become rusty, right?
rusty, exactly. So copper will become greenish after some time, and iron it will become reddish
Reddish.
when it reacts with water and oxygen. So generally,
Reddish
what
orange.
reddish orange, you can see that, right? Right. That is because of rust on it. So generally, it's a thing that metals are shiny while not while some objects are not shiny. Right now, like we have example of rock, sand, etc. That is one thing. Another thing is that you guys do this activity. Find the odd one out from the given example. You have example of aluminum, iron, copper, silver, and sand.
Sir, sand.
Sir, sand.
That is sand, no? Of course, that is sand. Okay, no? Also, for those of you who have started writing down, please pause because I will be telling you what to write. Okay, no? I will give sufficient time to write down. Okay.
Yes.
So that was the first basis of classification based on the appearance. We have shiny objects and we have non-shiny objects. So non-shiny objects are basically non-lustrous. So we have examples. We have plenty examples. We have so many examples like sand, hmm, soil, rock, etc.
Sir,
All these
glass
are
is
examples
also
of
like shiny, right?
The glass are also shiny. Yeah, they would be. They are also shiny. We can take that also. That can also be taken as one such example. Then another basis of classification is based on its hardness. So some of the materials can be easily compressed, right? And they can be easily scratched. While some of them cannot be easily compressed and scratched. Getting it? For example, you have a pillow, you can easily compress it, right? While if you were to have you have a piece of rock, you will not be able to compress it because it is hard.
Right.
So why it is hard? Because the particles of, for example, this diamond, they are very compactly packed together. They have no space between them. Like for example, you have this object and these two objects, let us say. So in this one, the particles of the objects are tightly packed. We know every object is made up of atoms now. So the atoms of these objects
Yes.
are tightly packed. Atoms are tightly packed. So there is very less space between them. But those objects that will be soft, they will be sufficient space between the particles. Atoms are loose. Atoms are loosely packed, meaning that there is space between them. So that
Sir,
is
like
one of the
water.
main, like water, very good, right now. Or you have a pillow like that. So that is one thing. So materials can be classified on the basis of hardness. Either they would be hard or either they would be soft, right? Like that. Furthermore, in nature, diamond is the hardest naturally occurring substance that is found on Earth. So it is the natural substance. Say we are saying it to be the natural substance, right? But there are some objects that are even harder than diamond. There are some objects that are even harder than diamond, but they are made in the lab. Okay, no? They
Yes,
are
sir.
made in the lab. Like for example, you have examples of like carbon nanotubes. So that is a type of substance that is even stronger than the diamond. Getting it now? So
Yes,
there
sir.
are some man-made substances which are considered more harder than diamond, but naturally it's diamond. Okay.
Yes, sir.
Like
Yes.
nowadays we have some objects like carbine is there, CARBYNE, right? Now it is said to be 3 times stronger than diamond. 3 times stronger than diamond. But is it a natural substance? No,
No. No.
that is man-made. So that is another basis of classification. Hope you guys have
Sir,
understood this one. Yes.
silicon carbide is also harder.
Which one?
Silicon.
Silicon or silicon carbide? You are saying?
Silicon carbide. Carbide.
Yeah. Yeah. It is also very hard. Silicon carbide is also very hard. Okay, no. We have examples of like tungsten. Tungsten is also very hard,
Yes.
right? So those are also very hard, but it is not harder than than the diamond. It is after diamond. If someone were to ask you which is the second hardest natural substance after diamond, in the first
After diamond,
list,
not
yeah,
before.
not before. I mean to say, in the first list, on the first position, you have diamond as the hardest natural
Hardest
substance
natural substance.
right now. But after diamond, which is the next hardest natural substance, so it is silicon carbide, as one of you was answering the
Sir,
silicon.
what about silicon?
No, silicon itself is not a hard substance. Silicon is a different thing. Okay, no? Silicon is not a hard substance. Getting it?
Yeah.
And it's like it's not hard in that sense. It is kind of breakable. Okay, it
Yeah.
is kind of
Sir,
breakable.
like wood is hard.
Yeah, wood is also hard. So we have several examples of hard and soft objects. So hard objects, generally all metals except for mercury
Sir, why
is
mercury?
hard, because mercury is found in the liquid state. Now mercury used in the thermometers. Uh, Earlier it was used
So
in the
that is
compact
that
fluorescent lamps
hard.
also. No, mercury is not hard. No, I'm saying all the metals are hard except for mercury. All metals except for mercury is hard, right? So iron is hard, copper, aluminum, all of the given metals are hard.
Yeah.
Apart from metals, we have example of wood, coal, stone, etc. They are also hard.
Silicon carbide.
Silicon, carbon, we can take all those ones also right now. So we can take example of diamond, or you can take example of silicon carbide, etc. Then we have n numbers of soft objects. This long list of objects that are soft, right? So hope that is clear.
Sir.
After
Yes,
this,
sir.
yeah, after this we have objects classified on the basis of whether
Soluble or insoluble.
exactly. So materials that can be dissolved in water upon stirring it are said to be soluble. For example, sugar and salt, both of them are soluble in water, right? They can be dissolved in water.
Yes.
But there are some materials that will settle at the bottom, like if you were to have sand and water,
Sir,
the sand
like
will be
mud,
mud, right?
sand, soil.
Exactly. So all those are insoluble
Sir, these
substances.
are the insoluble substances are like the thick, like that cannot be dissolved.
Yeah, their size would be bigger than usually bigger. Like they are having
Yeah.
size bigger
Like
size.
stones, clothes.
Exactly like that. Then we can take examples of oil also. Oil is also insoluble substance in water, no?
Yes, oil is also. Sir,
Right?
but it will float on water, right?
Yeah. Basically, it is not dissolving into it, no?
Yeah.
And it would be floating above it because oil has a less density as compared to water. Thereby, it floats above the
It is
water.
less denser than water.
Exactly. So it would be floating on it. So thereby not dissolving in it. That's why it will be floating on it. Right?
Sir, sand is
Yeah.
not soluble.
So sand is also not soluble. So we have examples of solid objects like sand, huh, which is not soluble, stone, sand, etc. But then we have example of liquid objects also like oil, which is not soluble in water and it would be settling on the uppermost layer. Right now, oil does not dissolve and deposits as a thin layer on the uppermost layer of water. So that was another basis of classification. Getting it?
Yes, sir.
Now
Yes,
you might
sir.
think of this, what is the main reason behind this? You know that the molecules of water are very small now, they are very microscopic. If you have to look at a single molecule of water, you have to take help of a microscope. Yeah, you
Yes, sir.
have to take help of microscope now. So for example, say that we have some water into this container and say that these are the size of the water molecules and all of them are connected now. All of the
Yes.
molecules would be connected with each other. So and then this is the size of a stone. So how will this stone fit in between the two water molecules? It is having a size much bigger than the space available between the molecules now. So how is it going to fit in that space? Hmm? So
Sir, it
rather
won't fit.
it won't, no. So rather it will simply settle at the bottom. Once you drop it
Yes.
into the water, it will be simply settling at the bottom. So
As
hope
it
that
is
was
also heavier.
But like, sir,
heavier
but
also,
salt is very small.
right? So upon dissolving salt, what
Sir,
happens
also
now?
it is heavier.
It is heavier, that is also one thing. Furthermore, when you dissolve salt, the salt particle disintegrates. Further, it will be breaking into smaller pieces, right? A salt particle is still bigger than the water molecule. But when you stir it in the water, the salt particle disintegrates, it breaks further into very small pieces. That's why it is able to fit in between those empty spaces and hence kind of disappears into those empty spaces. All of you getting at what I'm trying to say?
Yes, sir.
Good.
Yes,
So
sir.
that was another thing which we have learned. The substance which will be dissolving in the liquid water, not just water, there could be some other liquid substances also. So that would be called as soluble. But generally, we uh, talk about water in this sense. And there's one that will not be
Yes.
dissolving, and will be settling at the bottom as a precipitate that will be called as insoluble substance, right? So precipitate here is basically the sediment. It is basically the sediment. Getting this now?
Yes, sir.
Yes,
So
sir.
hope that is clear to everyone. Furthermore, based on whether an object would be floating on the water or whether it will be sinking on the water. Like for example, in this glass of water, you have two objects. You have some coins and you have a bottle cork.
What's that?
You know about bottle cork,
Yes, sir.
cork. It's a wood. It's a very spongy and soft wood, usually used to close the alcohol
Bottles.
bottles, beers,
Alcohol
or
bottle.
yeah, exactly. Right now, and the same cork is used in tennis, or I'm not in tennis, in the badminton cork also. Right now,
Yes, sir.
the shuttle cork. So it is very light in density. Right now, it is having a very less density as compared to water. So thereby, it will be floating above it. Right. While
Yes, sir.
coin,
Leaves will also float.
repeat again.
Leaves.
Leaves will also float. Right now. Okay. Then furthermore, talking about this coin, the coin will be sinking because it is having higher density as compared to the water. Now,
Like
ever
oil will
imagine
float.
oil will also float, right now, because it is having a less density. Ever imagine why a piece
Sir,
of needle sinks into water? Yes,
what did you do?
I was asking one question. Ever imagined why a needle sinks into water? Yeah, why a needle will sink in the water?
Sir, because
Why
it's
a
like made of
needle?
metal, right?
It's a metal, and usually metals have higher density as compared to water. So it is really not about the size. Here in this case, it is about the density.
Density.
Density. But then you guys answer this question, that why a needle sinks in the water but a ship floats on the water.
Sir, like it
Both
has
of them
less
are
density.
no. Both of them are made up of metals now. A needle
Yes.
and a ship,
Yes.
both of them are made up of metals. But a ship usually, if not overloaded with so many heavy materials, it will not be sinking, right?
Yes, sir.
But the thing about this needle is it will be sinking. Hmm? Think about this. Ever you guys have done this, like in a bucket of water, you dip your hand, you immerse your hand, and you observe the level of water rising. The level of water would be rising.
Yes, sir.
So
Yes, sir.
what basically happens now, that a given object would be floating whenever it displaces it displaces some amount of water, a significant amount of water. When it will be displaced by it will float. Like for example, as you put this bottle cork into this water now, you will find slightly the water level would be rising. Getting it?
Yes,
Yes.
sir.
Okay. So there's a principle called as buoyancy force. There's a type of force called as buoyancy force. So what is basically buoyancy force now? Say for example, you have a ship. Say that we have a ship on the water body. So due to the weight of the ship, it would be exerting a force in the downward direction now, right? Due to
Yes,
the
sir.
weight of the
The ship, the ship is made up of
Sir, it has
metal.
more mass.
Sir, the ship will be made up of metal, but it will be a bit light so that the ship
no
will
no
get float.
no, that
Sir,
is not the main reason.
because
Usually iron is used
sir,
now.
it has like less mass.
No, those are
More
not the
mass.
cause. That is not exactly the cause. Okay. See why it would be floating. We are trying to understand that concept. See, whenever like you guys would have, like for example, you put your hand into water like this, hold your hand flat like this, and try to push it under the water. You will experience a force from the water, like an opposite force being exerted by the water on your hand. Does it not feel like the water is also exerting some force on your hand? when
Yes,
you
sir.
push your hand like this?
Yes, sir.
So it's a property of water that it also exerts an equal amount of force. Getting it? It also exerts not necessarily equal, but it also exerts a opposite force. So that is called as buoyancy. That is called as buoyancy. And the downward force that is acted over here, it is due to the mass of object. Due to the mass of object, a downward force is being exerted. Okay. Now, when a body would be floating, if this downward force and upward force, if this mass of the object that is applying a downward force and the force of buoyancy, which is being applied by the water, if it is equal, the object would be floating. Try to understand what I'm saying. If it is equal, then the object would be floating. Getting it?
Yes.
Like the water and the human's mass.
The water and
Human.
the humans. Complete the question, Ira. It's a incomplete question. What are you saying?
Sir, I was saying that like on the human's mass and the water will be same.
Okay, yeah. Like in the case of the humans, it would be sinking if the humans are not kind of swimming in it, basically. See, basically talking about this iron ship over here, why it would be floating usually, because an equal amount of buoyant force would be acting upon it, right? But in some cases, if the ship is overloaded, if lots of peoples are onboarded on the ship, they are traveling, lots of load has been kept into this. Say that I have put lots of loads on this, so thereby the mass of the ship will increase too much now. So thereby, look at this arrow. This will increase, right? More force will be acted in the downward direction now. But as compared to that, the buoyancy force is less. So then in that case, ship will be sinking. So if the mass of the object is much more, then thereby, I mean to say, the force exerted by the object due to its mass is much more, right? And the force of buoyancy is less, then the object will be sinking. But if it is equal, then the object would be floating. Understanding what I'm trying to say?
Yes, sir.
Okay. Furthermore, another thing is that the iron ships are constructed in such a way that it is hollow from within. From within, it is hollow, right now. And the density of the ship is distributed in such a manner that it is evenly distributed. Getting it? So
Yes,
ships
sir.
are usually hollow. Ships are usually hollow, but iron needles are not hollow. It is usually compact, and thereby its density is more. The density of iron needle will be more, hence it
Yes, sir.
sinks in the water. The density of the ship would be less as compared to the density of the iron needle. That's why it will float and the
Yes.
needle will be sinking. So it has got something to do with the density. Getting it now?
Yes, sir.
So hope you would
Yes.
have understand this concept.
Sir, it's
Furthermore,
like it is like oil and the water.
yeah, oil and water, you can not oil and water basically. Here we did took a took a different example, by the way. By the way, you will get to know in higher classes that it's not just about density. There are several other things responsible for it. Like we have to understand about apart from density, we have to talk about buoyancy also. How much of water has been displaced by that
Yeah.
object. All that has to be taken into
Yes,
context.
sir.
Okay, but the general thing what you guys have to memorize is that an object would be floating if its density is less than water. It will be sinking if its density is more than water. Got
If
this?
the density of, I mean, if it is more than what
What?
the density is more than the water, it will be
It will be sinking.
and
If
if
it
it
is
is less, it will be floating.
floating. Very good. Okay, no? Next thing we are going to learn about is transparency. Right now. So on the basis of transparency, how objects are classified. So we have generally three kind of objects. Whether an object allows uh, all the light to pass through it, or just slight amount of light to pass through it, or none at all. We have
No,
transparent,
no light.
exactly, transparent, translucent, and
Translucent, and
opaque, right?
opaque.
So in the case of transparent, almost 100% of the light rays would be passing via the given object. We have the example of
Yes.
glassware, right? In the case of
And
translucent object,
some light will pass.
like for example, this one here is a frosted glass, a special type of glass that will only allow some amount of light to pass through it. Or you would have used butter papers in your project work also, yeah? Butter paper.
Yes, sir. Also in cooking, you use that paper.
Exactly, right? Or you can make a butter paper yourself also. Just tear out a page from a rough copy and just put some oil drops. Yeah, filter paper also is a translucent
Sir,
object.
like wood is opaque.
Wood is opaque. Stone is opaque.
Paper is also opaque, right?
Yes or no?
Book.
Paper is also opaque.
Paper. It really depends upon the type of paper you have.
Sir, sometimes if you put
But-
it against light, then you can like kind of see through it.
Yeah, like if the paper is really thin, like the one I am holding over, if it's a really thin paper, this one would be taken as a translucent object, right? But if I were to take another kind of paper like this one I'm holding in my hand, like this one is relatively thicker, so thereby it will be a opaque object. It will
Opaque object.
not allow the light to pass through. So it will really depend upon the thickness of the paper. Okay.
Yes.
So
And
the
in opaque, no light will pass. Like
exactly.
human. The shadow will reflect, right?
Exactly. So say we have a transparent object. So here the light ray would be completely passing. It completely passes. That's a transparent object. And then you have a translucent object. So in this case, only partial amount of light would be passing. Getting it? So we have several examples like a butter paper, frosted glass is there, right? Milk is also like you have a glass of milk and you light it using a torch from one side, from other side, you can just see some amount of light coming, right? So that can be taken as such as example of translucent objects, right? In some translucent objects, a very dim shadow will be formed in some cases, right now. So dim shadow is formed.
Yeah.
The shadow is not very dark, not very sharp. But in the case of opaque objects, the pathway of light is completely obstructed. So you have an opaque object like this. So either the light incident on that opaque object would be reflected back in the same direction. I mean to say, in the same angle at which it was coming, or it can be reflected in a irregular manner. Okay, like later on in the chapter light in higher classes, you'll be studying about reflection, where you'll get to that the manner in which the light rays would be reflecting, how it would be reflecting. But the basic thing here is that the incoming light ray would come in contact with the opaque object and it will return back into the same medium from where it was coming, meaning that it will
Like
not
it would
pass
reflect.
across it. Yes.
So like it would reflect.
I didn't heard it properly. What were you saying?
So it would like reflect of
Yeah,
the
reflect.
glass.
Exactly. It will basically bounce off from the given object, reflected from. Right now, like for example, you have a mirror right now, the one that we used to view ourselves. So from there, reflection is taking place right now. The back of the glass is.
Sir, our hand is opaque.
Our hand is opaque. Mirror is also an opaque object. The reason is that we have taken a clear glass and on the back of the glass we apply a coating of silver. On the back of the clear glass, a thin coating of silver is done right now. And if you ever happen to look at the backside of the mirror, it would be usually painted with red or some other color.
Yes,
right?
sir.
And if you were to slightly scratch it using something, as you scratch the paint, red paint, After that, you will observe a very shiny silverish thing. That is silver basically. Okay.
Okay.
So that's all about based on how much amount of light will it be
So
passing
that is
across it
why
or not.
it is opaque, right?
That is why it is opaque, right now.
Like
Because
transparent, sir, like you can see through it directly.
exactly, we'd be able to see through it directly, right? Okay. Now, apart from these, we have some other basis of classification also left to be discussed. The another one we are going to be talking about the whether they get attracted towards a magnet or not. Okay.
Okay, sir.
See, we have some objects in our nature, like we have objects like iron, we have cobalt, we have nickel, that would be attracted towards a magnet. We have iron, cobalt, and nickel. Generally, you would have learnt about only iron. Only objects made up of iron get attracted toward a magnet, right? This is
Yes.
what generally you would have learnt about right now. But apart
Yes,
from
sir.
iron, also we have some other objects also. We have cobalt and nickel. So objects like iron, cobalt, and nickel are attracted towards a magnet. They are attracted towards a magnet because they are magnetic substances. They are magnetic substances right now.
Yes, sir.
Furthermore, we
Sir,
know that
sometimes it will repel also.
no, usually all these objects now repulsion will take place between two magnets. Okay, now between two magnets,
Yeah.
repulsion will be taking place, not between a magnetic object and a magnet. So we have iron, nickel, and cobalt. All of them would be attracted. They are being attracted here. So talking about attraction towards a magnet, we have two kind of objects, magnetic and non-magnetic, based on whether they get attracted towards a magnet. We have two kind of objects. The first one is magnetic objects. The examples are, what are the examples?
Sir,
Yes,
iron,
Magnetic,
nickel,
sir.
and cobalt.
Sir, iron, nickel, cobalt.
iron, nickel, and cobalt. Good,
Magnetic object.
good. So these are the magnetic objects, and then we have a long list of non-magnetic objects. You guys give some examples of non-magnetic objects.
Sir, wood, glass,
Wood, glass,
Good.
book,
sir, sir, cloth, any fabric,
Cloth,
paper,
fabrics, paper,
sir, some metals like gold.
gold. Very good. And the list is very long,
rock.
right? Rock. Very good. Okay. By the way, I would like to tell you a story
Sir,
about the copper also. We can take so many examples, right? You guys have heard of the story of the discovery of magnet? Have you guys heard of this?
No, sir.
No,
Okay,
sir.
No.
let me take you 4,000 years ago. Almost 4,000 years ago, in Greece, there was a person. Basically, he was a shepherd. You know who's a shepherd now? So
Yes,
there
sir.
was a shepherd by the name of Magnus. Okay, so what he discovered that almost 4,000 years ago, while he was herding his sheep, you know what is herding now? So while he
Yes.
was herding his sheep, you would notice that a shepherd would always be keeping a stick with him, using which he would be directing and
Yes.
kind of beating or kind of directing the ships in which direction they have to go, right? And they would be keeping in. So basically, what he used to do now, this person Magnus, Magnus, what he used to do, he used to take a piece of wooden stick, and he on one of the end of this wooden stick, he used to attach a piece of iron object. Basically, one of the end of the wood was covered with iron. Okay, now to keep it
Yes.
strong, to make it strong. Okay, So one day what happened, while he was trying to pull this stick now, while it was actually stuck from a piece of rock. This like he might be laying down in the grassland, or he might be resting. So he got up, let's say he would have got up, and while he picked up this stick now, so he observed that it seemed to be attracted towards that piece of rock. Say that there was a piece of rock over here, and this was kind of attracted towards that rock. So thereby, while trying to pull this stick from that rock, he noticed that it seemed to be attracted towards that rock, drawn towards that rock. Getting it? Later on,
Yes, sir.
when studies were done, it was observed that this rock was a natural magnet, and it was called as magnetite. It was a natural magnet called as magnetite. Now, remember in the previous classes, I have been telling that all the different minerals are not found in their pure state in the nature. Like this magnet, was it found in this state in the nature?
No, sir.
It is
No,
not
sir.
found
They
in this
like
form, no?
crafted it to be that shape.
Exactly. But originally, it was found along with several other impurities also. So initially, it looked like a piece of rock. Okay, na?
Sir, like iron, like it was found in iron ore state.
Yeah, not in iron state, basically ore state, you mean to say.
Yeah,
The
iron.
magnetite is the ore. Okay, na? Just like iron is not found in the pure state, it is found in the form of iron ore. Getting it now?
Yes,
So
sir.
in this manner, the magnetism was discovered for the first time by the shepherd named as Magnus, and he lived in Greece. Okay, na, in a place called as Magnesia, and that is how the name of the magnet came. So the name of magnet came from his name. Okay, na? So
Sir, what was his
Sir,
name
like
again?
how sir, after how much time did they realize that it was like a magnet?
okay, how
Was his
like
name?
initially they were not very sure of it, but later on, as the science advanced, how many years later on, that is a question of debate. I'm not exactly sure of that, but for the first time about 4,000 years ago, it was observed that there are some objects like magnet. Right now, initially it was called as magnetite. Later on, when industrial evolution took place and um, things were
Sir,
being discovered, then it was, yeah,
what was the person's name?
his name was Magnus, Magnes. Okay, no? That was Magnus. He lived in Greece almost 4,000 years ago. So while one day he was basically trying to pull the stick, he observed that it was attracted towards a piece of rock. Okay, no? And that rock was basically ore of a magnet. You guys know about no ore, no? Ore of
Yes.
iron,
Yes, sir.
like we have
Or
learned
of
about
copper.
ore of copper, aluminum, etc. Getting it now. So any mineral is not found in the purest state. So for example, iron would be found in the form of hematite, which is one of the ore of iron. Uh,
Sir, also gold is
Hematite,
not found in its pure state.
exactly. Getting it. So we have examples of hematite. We have examples of siderite, etc., which are different kind of ores of iron. Similarly, the ore of magnet was magnetite. Keep that in mind. Furthermore, you guys noticed this thing that you yourself would have observed that a piece of iron, for example, you have a iron needle. If you keep it attached to a piece of magnet for a long period of time, that will also acquire some magnetic property. Okay. So these magnetic objects can also be made magnet using some methods. Later on in class 7th standard, you would be learning about that in detail. How, for example, if you happen to have a piece of iron object, you can make it magnet for a temporary amount of time. Okay, no? Getting this?
Okay, sir.
Hmm.
Yes.
Like if you
Yes,
happen
sir.
to have a iron needle, what you can do? You can just take an iron needle and take a copper wire. Okay. um, you have to remove the plastic covering of the copper wire. Okay, so take a bare copper wire. I mean to say it should not be covered with a plastic insulation. So roll it around this like this, and then connect it to a battery. Okay, connect it to a battery. Now, if you were to bring some small iron objects near to it, what you will observe now? This will now be attracted towards it. It gets attracted towards it. Now, as soon as you turn off the circuit, you turn it off, like from here, you break it, you break the flow of current, it will stop behaving as a magnet.
Sir,
So
in
that is some
compasses, do
interesting
they
thing which you
also
can
use
do.
magnets?
Where?
In compasses.
In compasses. Exactly. In compasses, magnet is used now. The needle of the compass, it is magnet. Okay, no? In one of the class later on, like right now we have to stick to the topic and we have to complete the chapter. Otherwise, I would have explained that how the sailors, how the navigators would be earlier making use of the compass to sail around the world.
Sir,
They
like
basically
it'll
had to
point
found
to
the
a
north.
sir, it will point to different direction like south, north, west,
Yeah,
or east.
yeah, good. See, basically, our Earth also behaves as a magnet. Our Earth behaves as a giant piece of magnet. Okay, now our Earth also
Yes,
behaves
sir.
as a magnet. Okay, now so in accordance to that, magnetic compass would be working.
So
Okay,
like
now let
gravity.
not gravity. That's a different thing. Okay, now I really would be discussing that topic, but we have to finish the chapter. Okay, now so let us get back to the topic.
Okay, sir.
Otherwise, we would be left. That topic would be left. So we have magnetic objects and we have non-magnetic objects. That is another basis of classification which we have learned. To see if any of the basis was left, we have learned about so far appearance of objects, hardness and softness, solubility,
Soluble in insoluble.
whether it is transparent,
Solubility,
opaque, or
basis.
Sir, what did you write about after solubility?
it is conductivity that we have to discuss. Okay, no?
That is conductivity.
Conductivity, whether a object would be conducting heat or electricity, or whether it does not conduct. On that basis, what kind of object we have.
Sir, we also finished the magnet attraction towards magnet.
Exactly, that one also. So the next we have got whether they would be conducting electricity or not, or whether they would be conducting heat or not. So on the basis of conductivity, so here we would be talking about heat and electricity. Heat and electricity. So on that basis, like we have some examples. Like for example, in a room heater, what kind of object would be preferably used?
Sir, heat.
Sir, can you repeat?
Like in a room heater, the coil of the room heater, what kind of object is used in that? Hmm? Should it be a good conductor of heat or should it be a bad conductor of heat? Should it
Sir,
easily
it will
become
be
warm?
good conductor of heat.
Good conductor of heat.
Exactly. Getting it. For example, in the electrical cables, in electric wires, what kind of object should I be using? Should I be using copper or should I be using gold? Should I be using iron or
Sir,
should I be using,
copper.
For what?
like in order to make electrical wires? So what kind of metal I should be using? Should I be using iron? Should I be
Sir,
using
copper.
Sir, copper.
copper right now? So in some cases,
Sir,
aluminum
it
is
is
also
about conductivity of electricity.
exactly right now. So there are some
Conductor of electricity.
conductor of electricity. Good. Although silver is considered as the best conductor of electricity, but is it really affordable?
No, sir.
No, sir.
So although it is very one minute. So that is the thing.
Sir, so because sir, because copper is like more affordable, then they'll use copper instead.
Exactly right now. So that is the thing over here. Then we have examples of objects that are bad conductors of electricity. So thereby they are called as insulator of electricity. Like we can have examples of so many examples are there which are the bad conductors of electricity that we can take. Hmm. Like for a piece of wood, it is a bad conductor of electricity, right? First of all, we are going to stick to the topic of heat. Okay, now we're going to learn about this heat. So based on whether an object would allow heat to pass through it or not, on that basis, we have good conductors of heat and we have bad conductor of heat.
Sir, also in ovens, like there'll be that coil that is like a good conductor of heat.
Yeah, exactly. There also. So say that I have taken a piece of wood, okay, and over here I have taken a piece of iron, and both of them is being held above a candle. Okay, both of them are being held above a candle flame. So in the first case, we have placed a iron rod, and over here you have put a wood. So you guys tell me, if I ask you to hold another end of it, like if you were asked to
Sir,
hold,
this will be very hot.
The
The
iron rod will be hot,
iron
and but
rod
the
will
wood,
be
it
hot,
won't be
and the wood
hot.
one will be, it won't be hot.
hmm, yes, Anna, you were saying the same thing, about to
Yes,
say the same
sir.
thing.
Sir, in
Yes, sir.
sir, in the
Sir,
heat, sometimes when you go in your car, like in the morning, then on the seat belts, it will
Hmm.
be like very hot.
Exactly.
So
sir,
even
for
the
cooking,
outside car windows, when you go to open them, it will be very hot.
What were you talking about, Hannah? Which thing?
Like
sir, for the cooking,
the car handles thing, like when during summer, especially when you
Hmm.
like when you go to open it, will be very hot.
Exactly. So
sir,
we have, yes.
for cooking, if we leave the iron, I mean the steel
Mhm.
spoon for wood, it won't be hot.
Exactly. See, basically, what is happening here? Like here, you have taken an iron rod. What happens? Why after few seconds or few minutes, the other end will also become hot, because the thing is that the heat was transferred from one end of the iron rod to the other end. It was being
Sir,
transferred.
also, it is a good conductor of heat.
It is. It's a good conductor. That's why it easily passed. Conduction, basically, the term conduction itself means to allow something to pass through it. To allow something to pass through it. That is what a conductor is. So it will allow the heat to pass from one into another. That's why after some time this end will become cold and your hand might get burnt. So you have to remove your hand from there. But in the case of wood, even if you were to hold it for like several minutes, the other end is not going to become warm. Right now,
Yes, sir.
Yes, sir.
the reason being that the rate of transfer of heat from other one end to another end is very slow. So slow rate of conduction. So that is the basis of classifying the objects on the base of heat, whether they are good conductor or bad conductor of heat. It is based on whether what is the rate of flow of heat in them, right? So can you guys think of which would be the best conductor of heat in nature? Which substance is there in
Sir,
nature which is the
iron,
best? No,
Sir, iron.
not necessarily iron. We have so many examples. Silver, silver, and
silver,
obviously
copper.
copper, objects like silver, objects like copper, they would be really considered as one of the best conductors of heat on Earth, right now.
Yes.
Okay,
Then
sir.
we have some other examples of metals like mercury. Why mercury is used in the thermometer? Because in coming in
To
contact
check,
when,
is there any fever for us?
yeah, of course, that's the general way to answer it. But the main reason behind use of mercury is that it's one of the best conductor of heat, and thereby whenever we put it under the armpit on our tongue, so it would be absorbing the heat from the body, and thereby due to absorption, it will be expanding. Because as we know that whenever
Yeah.
something would
Sir,
be
can I leave?
absorbing the
I
heat,
have
it
an
would be
exam.
expanding. Okay, almost the class is about to end. We have just 1 minute left.
Okay,
Okay,
sir.
so that is one thing. Getting it now? So furthermore, in the
Yes,
next
sir.
class, you will be continuing with
Yes.
the topic of electricity.